Hey guys, this looks like a fun one. It says, what's the missing area of this regular hexagon? We're given this piece has an area of 2 and this piece has an area of 1. If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. First, let's connect this vertex to this vertex and let's color this whole thing blue. We can do the same thing here and color that blue, and same thing here and color that blue. In any regular hexagon, these three will have the same area. And it's also true that if we reflect this over here, and this over here, all 6 of these blue triangles will have the same area. It could be a fun proof to go through it, but I don't think we need to for this video. Let's call the area of this blue triangle x, and so all of them will have an area of x. And now we can write our first equation. The area of this regular hexagon will equal 2 plus question mark plus 1. And the area of this identical regular hexagon will be equal to 6x. So we can say 2 plus question mark plus 1 equals 6x. On the left-hand side, 2 plus 1 is equal to 3. And if we want to get the question mark all by itself, let's subtract 3 from both sides. This positive 3 and this negative 3 will cancel each other out. And we end up with question mark is equal to 6x minus 3. Now we have a formula for question mark that involves something that we should be able to find. Figure out the area of any of these x's, and then we'll know what question mark is. This looks important. Let's put a box around it. And next, let's try to write some formulas involving x. I'm noticing the difference between this blue X and this green 2 area is this triangle. Let's color it red. And let's call the area of this triangle Y. Does that make sense, Y? So these 2 triangles make up the exact same area as this 2 right here. So we can say X plus Y is equal to 2. And then next, let's focus on this blue X down here. The difference between this blue X and this 1 would be this red triangle. We don't know the area of this, so let's call it Z. So this red and yellow triangle are the exact same area as this blue triangle down here. So we can say Z plus 1 is equal to X. And that looks pretty good. So we're ultimately trying to solve for X. We have 2 equations for Z and Y. So let's find some equation for Z and Y. These are both triangles, so it's going to be 1/2 base times height. This red triangle has a height that matches the hexagon. We label the whole hexagon's height as H. And then this red triangle, its height matches half of the hexagon. So it would be H over 2. Both of these red triangles have the exact same base. It goes from this vertex to where the yellow triangle starts. Let's label the base of both of those as B. So now the area of the triangle Z is going to be 1/2 times the base, which is B, times the height, which is H over 2. And if it's not obvious, we can clear this out. You can see the height of this triangle is the H over 2. And then for the area of triangle Y, we can do 1/2 the base of B times the height of H. And now we have 4 equations. I'm hoping we can solve it from here. Unfortunately, I have to go real quick. I'll be back in a couple hours. Hey guys, I'm back. Let's see if we can finish this thing. Looks like we just found the Z triangle is 1/2 base times this height, and the Y triangle was 1/2 the base times this height. We can make these 2 equations match if we multiply both sides of this equation by 2. This 2 and this 2 will cancel each other out, giving us H, and this side will be 2Z. So now we have both 2Z and Y equal to 1/2 BH. For the top one, in the place of the 1/2 BH, let's plug in Y. Does that make sense, Y? And now we have 2Z is equal to Y, and I think we're done with this equation. And now we have 3 equations and 3 variables, so we can definitely solve for X. And I think I see how to do that. Let's get this Z all by itself. Let's subtract 1 from both sides. This positive 1 and this negative 1 will cancel each other out. And on the right-hand side, we'll have X minus 1. And since we know Z is equal to X minus 1, in the place of this Z, we can plug in X minus 1. And next, let's distribute this 2 to both of these terms. It'll become 2X minus 2. And now I believe we're done with this equation. Let's gray it out and bring it down here. And now from here, let's get the Y alone. Let's subtract X from both sides of the equation. This X and this X will cancel each other out. And we'll be left with Y is equal to 2 minus X. And since Y is equal to 2 minus X, in the place of this Y, we can plug in 2 minus X. And now we have 2 minus X equals 2X minus 2. We have 1 equation in terms of X. We can definitely solve for X now. Let's clean things up a little bit and move this up here. Let's get both X's on the same side. We can add X to both sides. On the left-hand side, the negative X and positive X will cancel each other out. And on the right-hand side, 2X plus X is equal to 3X. And then from here, we can add 2 to both sides. These 2 will cancel each other out. And on this side, 2 plus 2 is equal to 4. Next, we can divide both sides by 3, and we end up with x is equal to 4/3. And that's what we needed. We needed to find x. So let's bring this up here, and in the place of the x, let's plug in 4/3. 6 times 4 is equal to 24, and 24 divided by 3 is equal to 8. And 8 minus 3 is equal to 5. This is the answer to our question. Let's put a box around it. The missing area of this regular hexagon is 5. And I ended up not putting a label because these didn't have labels, so I'm just matching the format. How exciting.